The objective of this project is to create an AC generator that will produce an EMF of 240 volts RMS based on the materials given. So here we have a basic AC generator. Two magnets of opposite polarity are placed adjacent to a coil which will rotate to cause a change in magnetic flux linkage, which then will induce an EMF. The induced EMF is given by the formula NBA omega sine omega t, or cosine omega t. So when the coil is vertical, the area cutting the magnetic field is at its maximum, and hence the induced EMF is at its maximum. In order to get 240 volts RMS, we need to have a maximum EMF of 240 root 2 when the coil is vertical. In order to get this value, these are the parameters we have defined. The coil will be 0.1 meters by 0.05 meters, giving a cross-sectional area of 0.005 meters squared. This area will cut the magnetic field lines from the north to south pole with a magnetic field strength of 0.5 Tesla. In order to rotate the coil to cause a change in magnetic flux linkage, we propose using a water turbine which will be linked to this coil via the axis shown. Here is the setup for the system. A water pipe will run from the top of the building to its base, and the turbine will be connected at the base of this pipe. So let's take a closer look at this turbine. Water will flow down the pipe, which will push down the vanes of the turbine, creating moments about its center, causing it to rotate. This will be linked to the AC generator to turn the coil as earlier mentioned. Rainwater will be collected at the top of the pipe and drained down the length of the building. As the water falls, it will lose gravitational potential energy and gain kinetic energy. But first we need to determine the velocity at which the water pushes the turbine. As gain in kinetic energy equals to the loss in gravitational potential energy, V equals to root 2GH as shown. This is assuming no air resistance and that water has zero velocity at the top of the pipe. Hence, we can find the angular velocity, omega, using the formula V equals to R omega. As different HDB flats are of different heights, each water turbine will need to be customized to the building it is attached to, as the output voltage is directly proportional to the radius of the water turbine. We can calculate the required radius of the turbine using the formula shown. For example, if the building is 50 meters high, the radius of the turbine will be approximately 4.6 centimeters. Of course, there are certain limitations or drawbacks in our project. The carbon brushes will wear and tear over time, thus requiring regular replacement. Also, the project requires rainwater for it to function. Therefore, on days that it does not rain, the system might not have enough water to function. Leaves and litter might clog up the system, causing higher resistance as the water flows down the pipe, resulting in lower EMF induced. In addition, there is the risk of acid rain which will corrode the pipes, resulting in high maintenance. In our earlier calculations, we assumed that the rainwater has a velocity of 0 at the top of the pipe. However, this will likely not happen in reality, as rain already has kinetic energy at the top of the pipe. Thus, the EMF induced will be higher than calculated. To correct this, we suggest connecting variable resistors to the circuit to reduce the output voltage to the desired value, in this case, 240 volts RMS. The strength of our project is that our system is environmentally friendly and makes use of nature's processes to fuel the system. The water will also be recycled into drinking water, as it will be funneled into the Kallang Basin and Singapore's reservoirs. This project is also sustainable, as there is no use of electricity to run the system, thus increasing efficiency. This is the end of our presentation. Thank you.